Hey everyone, and welcome to Chapter 5 on polynomials and polynomial functions. Polynomials are, in some ways, some of the most fundamental objects in algebra, so they're going to be pretty important for us. A lot of other things that we do are going to be based off of them. So before we jump into what polynomials are, let's review a little bit. So if you have an algebraic expression, then remember that the terms are the things that are more or less separated by addition and subtraction. That is to say that the terms are either constants or a product of constants and variable expressions. So each of these labeled things here is a term on its own. A monomial is an expression that is the product of non-zero constants and variables which are possibly repeated. In other words, a monomial only has one term. And getting into specifics now, a monomial in one variable looks like a times x to the n, where a is a constant and n is a non-negative integer. It could be 0, could be 1, 2, 3, but it does have to be an integer. Now, if you take a monomial or a sum and difference of monomials, you get what's called a polynomial. The monomial has one term because of the word mono meaning one. Binomial has two terms, right, like bicycle. Trinomial has three terms because of the word tri, as in triceratops. And finally, we come to the polynomial, which has its roots in the Greek word poly, meaning many, and nom, meaning delicious. The degree of a monomial is the sum of all of the variable's exponents. So if we look at these examples here, this first guy, which is just x, its degree is 1. Whereas 7x squared has a 2 as an exponent, so its degree is 2. And next up we have 10yz. Although the individual variables only have an exponent of 1, we're adding together all of the variables' exponents. So actually, the degree of this monomial is 2. And over on the right-hand side there, we have 3, which is just a lonely little number. We are considering constants to be monomials with degree 0. So we know that a polynomial is a bunch of monomials smacked together with addition and subtraction. So the degree of a polynomial is defined to be the maximum degree among all of its terms. This x plus 7x squared plus 10yz plus 3 is a polynomial in 3 different variables, x, y, and z. And the maximum degree of its terms is 2. So the degree of this polynomial is 2. We talked a little bit about functions in Chapter 3. So remember that a function is a relation in which every input goes to exactly one output. And polynomials are great examples of functions. They're very classic. Specifically, a polynomial function f of one variable x with degree n is a function that looks like that. F of x equals a0 plus a1x plus a2x squared plus ... all the way up to an x to the n, where a0 through an are real numbers and an is not equal to 0. So here we have a polynomial 5x squared minus x minus 4, and what we want to do is calculate some different values. We're evaluating f of x at 3, negative 1, and 0. So let's go ahead and do that real quick. So for f of 3, what we're going to do is take x and we're going to replace it with 3. Everywhere I see an x, I replace with a 3. And that's it. Of course, we have to simplify following the proper order of operations. All right, for f of -1, same deal. Be careful because you have to remember to put your parentheses around your number, -1, just so you're keeping track of everything. And 2. Lastly, we have f of 0. This is usually an easy one to do. And we get -4. So on the discussion of functions, they're kind of important objects in mathematics. And one of the things that we want to do is kind of move towards thinking of functions as these objects of study, just like numbers. And so, you can add, subtract, multiply, divide numbers. If we want to be able to do the same thing for functions, we have to define it. So if we have two functions, we wanted to add them to get another function as a result. Got to think about how we would define it. Right? The issue here is that I want to take a function f and quote-unquote add it to the function g and get another function as a result. So it's not as if I'm adding numbers, I'm adding functions. But the way that you define it is pretty intuitive, actually. So it's pretty much exactly what you would expect. The sum of f plus g as a function evaluated at x is just f evaluated at x plus g evaluated at x. This is kind of like maybe not super meaningful to you at the moment. So let's look at an example. So let's suppose your two functions are 18x and -5x squared. Then when you take the summation function, you would just add those two expressions together, getting 18x plus -5x squared. Which gives us a notion of adding and subtracting polynomial functions. So polynomials, as a subclass of functions, can be added, subtracted, multiplied, and divide, and that's kind of what we're going to be doing over the course of this chapter. All right, so for an example to close things off, if f of x is equal to 5x squared minus 4x minus 1, and g of x is x squared plus 3x plus 8, we want to find these three things. So first up, we want to find f plus g of x. This is just going to be the sum of these two expressions together. So we have 5x squared minus 4x minus 1 plus x squared plus 3x plus 8. And let's see if I have any like terms. 5x and an 5x squared and an x squared, a -4x and a positive 3x, and a -1 and a positive 8. So f plus g of x is 6x squared minus x plus 7. If we wanted to compute f minus g of x, we would be doing pretty much the same thing. However, I want to bring your attention to this guy over here. When we subtract two functions, we are subtracting the entire expression that defines the function. So we are subtracting all of x squared plus 3x plus 8, which means we got to distribute our negative signs. do I have any like terms? 5x and negative x squared. Negative 4x and negative 3x. Negative 1 and negative 8. That would be the function f minus g of x. And these last two guys, what we're going to do is evaluate these new functions at particular points. For f plus g of 8, we're going to plug 8 into that guy. Follow our order of operations. And we get 383. Last up, we're evaluating f minus g at negative 2. This is not too terrible. And so we get 21. It's not too bad, just as always, you gotta watch out for those negative signs. Well, that about wraps it up for this video. Next up, we're going to be taking an in-depth look at exponents because it's going to become pretty important for us when we talk about multiplying and dividing polynomials, which can get kind of gross. So look forward to it.